Hello everyone, my name is Mark Miro, and for my Thermodynamics Quiz 3, I'll be going over the Brighton cycle specifically for ideal gases. I'll be talking about some important relationships, how to solve for temperature and pressure, how to solve for the compressor and turbine work, the efficiency, and the Carnot efficiency. So to start, some important relationships. It's important to note that for the combustion chamber Q in and heat exchanger Q out, the pressure is always constant. So this means that the pressure at point 2 is always equal to the pressure at point 3, and the pressure at point 4 is always equal to the pressure at point 1. We know that this is known as an isobaric relationship, and I will highlight the isobaric parts in yellow so that we remember. Next, another important relationship for the compressor and turbine is that entropy is always constant. This means that the entropy at point 1 is equal to the entropy at point 2, and the entropy at point 3 is equal to the entropy at point 4. We know this as isentropic, and I will highlight that in blue so it is easier for us to remember. Next, I'll be showing you how to solve for temperature and pressure. So we just talked about the isobaric and isentropic relationships. And so from 1 to 2, we need to use the isentropic relationship to solve for our temperature and pressure. From 2 to 3, we see it's yellow, and so we have to use isobaric, and the only isobaric relationship we know is ideal gas law. So I'll just write ideal gas. From 3 to 4, isentropic, so we need to use our isentropic relationship. Isentropic. And then from 4 to 1, we need to use ideal gas. We know the ideal gas law, it's PV is equal to mRT. And for the isentropic relationship, we need to use the one with temperature and pressure. And so we use T2 over T1 is equal to P2 over P1 K minus 1 over K. Now, solving for compressor and turbine work. Firstly, for compressor work, we'll call it W12. We know that it is the enthalpy at point 1 minus the enthalpy at point 2. And this can be written as Cp T2 minus T1. For the turbine work, we know it's the same ratio, and it'll be 3,4 H3 minus H4, and that is just Cp T3 minus T4. Next, we'll be going over efficiency. So we know that efficiency is equal to the net work over the heat in. We know that net work is simply the turbine work minus the compressor work, and we know that Q in is equal to the H3 minus H2, which is simply Cp T3 minus T2. So for efficiency, we know that it's turbine work minus compressor work over Cp T3 minus T2. Lastly, for Carnot efficiency, we know that it is 1 minus T low over T high. And in this case, we know that T low will always be right after the heat exchanger at point 1, and T high will be right after the combustion chamber at point 3. So it'll be T1 minus T3. And that is how you solve for Carnot efficiency. Thank you for listening to my short summary on the Brighton cycle, and I hope you enjoyed.